Good morning, everybody. Welcome to a overcast, well, hopefully soon to be rainy. My lawn can use the rain. Monday morning of Chem 1211 with your host, me, Dr. White. Important announcement. Remember, Wednesday after class, I will be sending out the password email. Excuse me, I'm getting all choked up over everything this morning. But anyways, password email for test number 4. We gotta get that figure fixed. But anyways, test number 4, and we've already talked about it will cover equilibrium chapter and acids and base chapter. And the announcement already went out. You can read that because you should have gotten an email with that. Uh, that's one thing. Number two, Wednesday morning, and I will take it out of the video, I will give a presentation or to really teach you how to do a good interview. If you're ever planning on getting a job, or if you're ever planning on getting into a school like nursing or other things, I highly recommend you come. We'll start at 10 a.m. Labs are at 9, but this will be 10 a.m. Don't forget, labs should be handed in on time. I'm not giving any more extra time for labs. And finally, well, actually, second to finally, that makes sense. Hopefully it does. Uh, don't forget the deadline, and this is a firm deadline for the extra credit project is this Wednesday. You don't have to do it, it's optional, but it's 10, 10, notice my eyes pop open, 10 points will do that. 10 bonus points for you. It's like getting 10 more points on any test. And I'd highly recommend that before Wednesday, either come to my office hour or email me, and I'll check and tell you, no, this is wrong, you got to change it. So you can get 10, 10 bonus points. And don't forget tonight from 6 to 7:15 on Zoom, I have my office hours. All right, what are we doing today? First of all, I'm going to give my world famous review for the next test, test number 4, test number 4. And then after that, we'll go through the pH practice problems. Oh, that reminds me. Besides the uh, how to interview lesson I'll give you, Dr. White has a special surprise. I'm not going to tell you until Wednesday. All right, let's get started. Thumbs up, people. Do you see collision theory? Thank you. All right, let's go through test number 4 review. Remember, everything you're going to see now is in the test number 4 review file in the lecture folder of Blackboard. First thing I taught you was the collision theory. And you should know what are the 3 things that make up the collision theory of reactions. And that is, in order to have a reaction occur, molecules must collide for a reaction to occur. Next, the colliding molecules must have a minimum amount of energy, also called the activation energy, for a chemical reaction to occur. And finally, molecules must collide in the proper orientation for a reaction to occur. So, collision theory, in order to have a reaction, molecules have to collide. When they collide, they just can't go dink. They got to have enough activation energy, boom, to have a reaction. And finally, they have to be in the right orientation to occur. Ooh, that reminds me. Everybody see this? They have to be in the right orientation to occur. And now for the bad joke of the week. Everybody know what that is? Spider doing push-ups on a mirror. I said it was a bad joke of the week. Dr. White doesn't lie. All right, back to chemistry. Now, I talked about, notice how I used imperial we. I talked about, and you learned about the reaction rate. And that's the rate at which products are made or reactants are consumed. In other words, when you're making something, how fast are you making it? Now, factors that affect the reaction rate, or how fast the reaction goes. And the first thing is physical nature of the reactants. Are they gases, liquids, or solids? That will affect it. Next, the reactant concentration. The more concentration, the more reactants you have, the more collisions, the faster it goes for most reactions. Not all, but just about most. And once again, I'm being subtle. And that is the reaction temperature. And the reaction temperature, you should know. There's a rule of thumb. Notice I have my stars in important. I didn't even write it, handwrite it. It's typed. And the rule of thumb, and the rule of thumb is true about 95, 97% of the time, you should know. The rate of a chemical reaction doubles for every 10-degree increase in the reaction temperature. Again, a factor that influences the rate of reaction is the reaction temperature. And the rate of a chemical reaction, you should know, doubles for every 10 degrees increase in the reaction temperature. And the final thing that will affect the reaction rate is a catalyst. And you should know, what is a catalyst? It's something that makes the reaction go faster. And how does the catalyst work? And the answer is, it lowers the activation energy. And by having a lower activation energy, it's easier to react for reactants to get to the product. So what are the factors that influence the reaction rate? The important ones, reaction temperature and catalyst. And the other ones are important too, but if I had to choose, those two are the most important. Now, next I talked about energy diagrams. And there's two types of reactions, exothermic and endothermic. An exothermic reaction gives off heat or energy. And for this class, we'll call heat energy, which it is. Endothermic, you have to add energy, which in this class we'll talk about as heat. And therefore, you should know exothermic, exo means outside, gives off heat, endo, inside or in, you have to add heat. And I showed you the energy diagrams. And you know something? I'm going to share the fun. Eh. haven't done it today yet, so I did actually. Thumbs up, people. Do you see my whiteboard and the problem? All right, it's time for me to decode it. For the following reaction, draw the energy diagram for A plus C goes to H, J plus heat. Please show the activation energy. Your turn. Have fun. For those who don't know, this is National Teachers Week or Education Week. So to make Dr. White happy and honor Dr. White for the job I'm doing, turn on your webcams. If I pester enough people, you might. Everybody, turn on your webcams. Come on, help Dr. White out. You can do it. And when you're done, you can give me a thumbs up. If you're not done, you can give me a thumbs down or don't do anything. Or I can get fancy. All right, let's do it. For an energy diagram, on the y-axis and the x-axis, and you don't have to put the letters there. I do in case you forgot which is which. On y, we have energy. On x, we have time. Now, A and C have a certain amount of energy. So I'll do it right there, A and C. Now, you never create or destroy energy. And the amount of energy A and C has, the reactants, equal the total energy on the product side. However, some of the energy is lost in heat. Therefore, H and J have less energy for exothermic because you've lost some of it as heat. And now you go over the hill and down the hill to grandmother's house. We go, no, I'll never stop saying that. And you have this hill you go over and down to the products. And where you start out to the top of the hill is the activation energy. And that's how you do it. That 6 months ago, you wouldn't guess you know how to draw an energy diagram now. See how much you're learning in my class? Doesn't that feel good? Everybody say, yes, Dr. White. Thank you. All right, back to the review. Well, this is part of the review. Now, there's a special type of chemical reaction called the equilibrium reaction. And the equilibrium reaction involves reversible reactions. And in equilibrium, and I'll just draw one up here. When you see the double-headed arrow, that's an equilibrium reaction with a reverse reaction. What am I doing here? Hang in there. That's better. Dr. White just had a brain freeze. Ah. Anyways, A and B, if you mix them together, makes C and D going forward. If you take C and D and mix them together, you'll go to the left and you'll get A and B. Now, important thing you should know. And if I have it in red, you know, and underline, you know, in a chemical equilibrium reaction, the forward and reverse rates of reaction are the same. That's always true for an equilibrium reaction. Now, for the following equilibrium reaction, there's something called the equilibrium constant. Now, you should know how to develop that. And the equilibrium constant is on top the reactants of the reactants to products. And that's on the right of the arrows. And on the left, at the bottom of this equation, are the reactants. And for each reactant or each product, you put on the top the concentration, the bracket is moles per liter of that product to the power of the coefficient, and it's times. Students like to put plus, and that's wrong. Puts times each of the products on top to the coefficient. And then underneath, you have each of the reactants concentration to the power of the coefficient. Remember, coefficient is the number in front of a chemical or an element in a balanced chemical equation. Now, when we talk about the equilibrium constant, KEQ, it tells us about how complete to the right the reaction goes. The magnitude, how small or large KEQ is, conveys information on how far to completion it goes. The larger K equilibrium, the more the products are made. Thumbs up, people. You see, predict the stock market and give that to Dr. White. No, I wish. Yeah. And there you go. I'm going to share some more with you. Am I being nice today or what? For predict the relative amounts of products and reactants for A plus D is in equilibrium with E plus F, and K equilibrium constant, KEQ, equal 1.0 times 10 to the 25th. And when you're done, give me a thumbs up. All right, I think everybody's done. Let's do this. And the answer is the product's concentration are greater than reactants. And how do we know this? By this number. When K EQ, the equilibrium constant, is greater than 1, this is true. And when K EQ is less than 1, and I'll put much less and much greater here, then this is true. Reactants are greater than products. And that's the important thing about K equilibrium. Now, next, I taught you the Chandler's principle. I'll never ask on a test what it is, but an equilibrium shifts to the side to reduce the stress put on an equilibrium. And you should know concentration effects and temperature effects. Remember, exothermic reactions and endothermic reactions, something I don't have here, but you should know. An ice bath removes heat. Think if you go outside and you're cold, that's because the heat is leaving your body, removes heat. And boiling water adds heat. Since we're doing good on time today, and every day, I'm going to have an example for you to try out. And thumbs up, people. Do you see the problem up there? Thank you, fast thumbs up, people. And the question is, for the following equilibrium, Q plus S is equilibrium with Z plus W plus heat. What happens to the concentration of Q and Z if I add more S? And also B, if I put the reaction in an ice bath? Have fun. Or, as professionals say, enjoy yourself. That was pretty lame. And all of you are turning on your web camera. Thank you. All of you don't have your web camera on. Well, turn it on and I'll still say, thank you for coming to class. Dr. White is not a webcam discriminator. While you're doing that, I'll be back in a second or maybe a minute. I gotta go get something to show you. All right, is everybody done? Give me a thumbs up if you're done. All right, not to scare you, but I thought I'd show you something. And that is that one of the instructors I know, they came over the other day. We were socially distanced. He had something, and notice chemistry, mass. This one's periodic table. This one's all sorts of chemistry stuff. Aren't they cool? Plus, they're well made too, with adjustable ear straps. And the reason I thought of that is something more serious. All of you, I hope you've gotten your vaccinations. They're available now. They're not hard to get in. My neighbors all have them. In fact, yesterday from socially distanced, my neighbor was very happy because her son turned, I think, 5 or 6, and he'll be able to get a vaccine soon. And she and her husband are, she teaches grade school, and she's been doing that face-to-face, very brave lady. And get your vaccine, get vaccinated. If you look at the numbers, the largest group getting infected now are not older people like us. I should say me, not you. You're all younger. But anyways, get your vaccine. All right. Let's get to work. Everybody see Q on the screen? Maybe not. All right, you see the problem on the screen now? Thank you.
Yeah.
And whoever just said that, thank you. All right, at equilibrium, there's a certain amount of Q, S, Z, W, and E. When you add more S, the equilibrium says, oh no, we've got too much S. We've got to get rid of it. The only way you can lower the amount of something is to react it. It's consumed. And when it reacts, it goes in that direction, and Q and S are reacted. When something reacts, it's consumed. Remember my French silk pie, which I've been good. I haven't gone out and bought one. I've been thinking about it and say, no, don't need it. And when something is consumed, the amount you have decreases, goes down. Now, when Q and S react to get rid of the excess S, what do you make? More Z, W, and E. So if you make more of something, in this case Z, the amount you have will increase. And this will go up. Now, when you put the reaction in an ice bath, this removes heat. And at equilibrium, there's a certain amount of heat. Now you've removed it. And what happens? Equilibrium says, oh no, we don't have enough heat. We need more heat. How does it make more heat? Q and S react to make more Z, W, and heat. Well, in that case, if Q reacts, the same thing happens as before. This will decrease because when anything reacts, it's consumed and you have less. And when you make more heat, you're going to make more Z and W. And when you make more of something, that's better. When you make more of something, the amount you have increases. And that's Le Chatelier's principle. Now, next thing I talked about were acids and bases. And you should know that in Bronsted-Lowry acid, or just for this class, an acid, what is it? It's a proton donor. Remember, proton, H plus. Now, what is a base or Bronsted-Lowry base? It's any substance that it can accept the proton. A base is a proton acceptor. So therefore, remember, if we were face to face, I do this. If I were an acid, I am a proton donor. Take my proton. If I'm a base, I'm a proton acceptor. Come on, give me your proton. You should know that. Now, you should know certain key acids. HCl, hydrochloric acid, H2SO4, sulfuric acid, and HNO3, nitric acid. Now, certain key bases you should know. Sodium hydroxide is a base, potassium hydroxide is a base, ammonia, NH3 is a base. And one I forgot to write here. Uh-oh. I'm having a little problem. It happens once in a while. Let me close some stuff. Let me do something real quick. That's why. All right, for those wondering this happened, you might want to use your own, because all the stuff I'm doing and stuff I did earlier this morning, I forgot to use, there's a great product called Sea Cleaner. You can get it free, download. Don't get the professional version. You don't need it from File Hippo or other places, from Sea Cleaner themselves. And I just wiped out or deleted about 250 temporary files, which was causing problems on my PC. And now it's time to open up everything I closed. I just found out the other problem. Once in a while, I click on my, I don't realize I'm doing that. I clicked on there's a button, it's right there when you do larger web layout instead of print layout. And I just realized that's what I did. All right, let's get back to work. Another base you should know, this is a base, and this is sodium bicarbonate baking powder.
Sorry, Dr. White, we can't see the.
Oh no! Thank you for telling me. Can you see me?
Yes.
Oh, good. Can you see bases now?
Yes.
Thank you for letting me know, Erica Michelle. All right, let's go through this again. Strong acids you should know. HCl, H2SO4, HCl hydrochloric acid, H2SO4 sulfuric, HNO3 nitric. I'll never ask you their names, but from the formulas you should know those are acids. Bases you should know. Sodium hydroxide, NaOH, potassium hydroxide, KOH, and ammonia, NH3. And the one I forgot to put on this list, but I'm putting on now, you should know sodium bicarbonate, otherwise known as baking powder. Now, when it comes to water, which is a miraculous chemical, keeps us alive, there's something called the dissociation of water. Water can react with itself, equilibrium. It's mostly to the left, which is why the top arrow is tiny, the bottom arrow is big, but enough of it happens, this is critical, things going on in our life and our body. You form H3O plus, the hydronium ion concentration, and OH minus, the hydroxide. And by the way, Kelly, thank you for letting me know also. And at equilibrium, since water messes up the equilibrium constant, which I taught you earlier, for any equilibrium, chemists decided let's take it out, but we can come up with a constant, which is no longer equilibrium, but we call it Kw, named after me, Kenneth White, I wish, the ionization constant for water. And you should know, and this will be given to you in important information on here. I have one, and usually I write 1.0 times 10 to the minus 14. The hydronium ion concentration times the hydroxide equals this. And this is at room temperature. Now, what's an acidic? What's a basic? What's a neutral solution? And you should know an acidic solution has the concentration of hydronium ions is higher than the hydroxide. Basic solution, a solution in which the hydroxide ion concentration is higher than the hydronium, H3O plus. And finally, neutral solution, a solution in which the concentration of hydroxide and hydronium ion concentration are equal. And to recap, For acidic solution, the hydronium ion concentration is greater than hydroxide. For basic solution, hydroxide ion concentration is greater than hydronium ion concentration. And for a neutral solution, hydronium ion concentration is equal to hydroxide ion concentration. And you should know what is acidic, basic, and neutral. Now, time for Dr. White to get personal. In your stomach, the liquid in there is acidic. Why? Because there's an acid present, hydrochloric acid. That's always one of the wonders of for my mind, that I have in my body cells that synthesize, that's the fancy word for make, hydrochloric acid. And why is the pH, or why is your stomach acidic? Because the hydronium ion concentration is greater than hydroxide. There's an acid present, HCl. Now, doing this, acidic, basic, and neutral, that's hard. Chemists came up with a better way to do that for solutions, water solutions. That's the pH concept. I'll never ask on a test or to final, what is the pH scale or concept, but it's a scale of small numbers that are used to specify the molar hydronium ion concentration in an aqueous solution. And you all know aqueous means water is the solvent. Now, this will be given to you in important information. pH equals minus the log of the hydronium ion concentration. Don't tell anybody, but my special gift to you this semester is, if the hydronium ion concentration is 1.0 times 10 to the minus x, then pH is x. This you should know. It will not be important information. And this is probably one of the most important things I'll ever teach you. All right, pH is a scale that goes from 0 to 14. In the middle, 7, you have neutral solution. Hydroxide equals hydronium. Below 7 is acidic. The closer to 0, the more acidic. Above 7 is basic. The closer to 14, the more basic. And again, the pH range is from 0 to 14. Excuse me, the lower the pH, the more acidic a solution is, the higher pH, the more basic. And you should know the scale. This is probably the most important thing I'll teach you this semester that you can use in your daily life and professional life. Now, there's something called a buffer solution. And a buffer solution is a solution that resists major changes in pH when small amounts of acid and base are added. So if I have a buffer solution and I add a small amount of a dilute acid, what happens to the numerical value of the pH? It stays the same. If I have a buffer solution and I add a small amount of a dilute solution of base, what happens to the numerical value of the pH? It stays the same. If I look at the time, it's time for Dr. White to take a break, and you too. I'll be back in 5 minutes. Come back at 10:55. We'll continue with the review, and we will continue, and I'll do the practice problems for chapter 14. See you in 5. Time to start again. All right, quick public service announcement from me, Dr. White. Over the weekend, I was writing the lab you're going to do this Thursday and Friday from Beyond Lab Z. And guess what? It doesn't work well, which is rare there's a bug in there and I'll let them know about it. There's another lab that will do this. This is good that I tried out. It works perfectly. So only the names have been changed to protect the innocent. Oh, that was a bad joke. But anyways, I will be putting up that lab. So when you see it, you'll see just a slightly different name, like a big slightly different, but it will still be with titration. All right, let's continue with the review. Speaking about titrations, and I better check. Thumbs up, people. You see titrations on your screen. Thank you. All right, titrations. That's when you add a amount of acid, known amount of acid, to known amount of base, and one of the two you don't know the concentration, the other one you do, and at neutralization. What do I mean by neutralization? If I have an acid plus a base, and this is an equilibrium, let's say the equilibrium goes that way, you make a salt, and at neutralization, the acid and base neutralize each other and you get a salt, and the pH equals 7. And at neutralization, moles of acid equals moles of base. And an equation, when you have a monoprotic acid, you can get by with mils of acid times molarity of acid equals mils of base times molarity of base. And with that, we can now determine if you're given this, you'll solve for this or the other way around. And I showed you, and I'll show you how to do that. And that's the review. All right, let's do chapter 14. First of all, any questions about acids and bases before I move on to the problem set? I got to stop doing that because I've got to push my ears back further again. Oh, that was awful. All right, thumbs up, people. Do you see practice problem? Thank you. All right. All right, first you should know what is an acid. A Bronsted Lowry acid, that's a proton donor. What is a base? A proton acceptor. Now, as I mentioned earlier, you should know the chemical structures for acids and bases. And here I'm asking you, are the following acid, base, or salt? NaHCl, hydrochloric acid, sodium hydroxide, base, sodium chloride. Remember, please pass the NaCl. That's salt. Hopefully you know that by now. H2SO4, sulfuric acid, and acid, NH3, ammonia base, and HNO3, nitric acid is an acid. Now, if the pH of a solution is 1.0 times 10 to the minus 3, or the solution, yeah, I got ahead of myself. The solution has a hydronium ion concentration of 1.0 times 10 to the minus 3, then what is the pH of the solution? Is it acidic, basic, or neutral? So what are we trying to find? pH. What are we given? The hydronium ion concentration. And pH, you'll be given important information. Ooh. I highly recommend before test number 4, you all look at important information, test number 4 file that's in the lecture part folder of Blackboard to see what you have to memorize and what you will be given. Stuff you'll be given, you still have to know how to use. And if we put in the hydronium ion concentration, 1.0 10 to the minus 3, remember if this number is 1.0 times 10 to the minus x, then the pH is x. In this case, x is 3. Therefore, the pH is 3. And note, here I give you the pH scale. You should know this. It will not be an important information. pH 0 to 14. pH 7, neutral. Above 7, basic. Below 7, acidic. So therefore, 3 is less than 7. This is acidic. And here's one for you to have fun with. If the hydronium ion concentration is 1.0 times 10 to the minus 10, then what is the pH of the solution? And is it acidic, basic, or neutral? And I would give you an important information, this. Your turn. I think on Wednesday, help me out. I'm going to be trying to get the Guinness Book of World Record for the highest percentage of students with their web camera on. I wonder if that will work on you guys. See how sneaky I am? Throw a little guilt in your direction. Oh, I think everybody's done. So I better get to work. And if we look at the problem, the question is what? Determine the pH. What are you given? The hydronium ion concentration. and pH equals minus the log of the hydronium ion concentration, and that's minus the log, we're given it right here, 1.0 times 10 to the minus 10th. And when this is 1.0 times 10 to the minus x, the pH is x, excuse me. And in this case, x is 10. And this is basic because it's greater than 7. And that's how you do it. And I have a few more, which you can do at your leisure. I hope you are. Now, let's look at number 7. Everybody see number 7 on your screen? Thank you. All right, if a solution has a hydroxide OH minus concentration of 1.0 times 10 to the minus third, then what is the pH of the solution? And is it acidic, basic, or neutral? Well, it takes 2 steps. Why? Because you're trying to find pH, and pH is minus the hydronium ion concentration, but we're given the hydroxide. So what do? You take this and step 1, solve for hydronium. How do you do that? Hydronium times hydroxide equals 1.0 times 10 to the minus 14. And to solve for hydronium, I want to get rid of hydroxide. I divide this side by hydroxide. That anything divided by itself becomes number 1, cancels out. But whatever I do to one side, I have to do to the other. And I do. And now I have hydronium ion concentration equals 1.0 times 10 to the minus 14 divided by hydroxide. Put in the number, do the math. Well, am I done? No, I'm trying to get the pH. And now we have step number invisible, number 2. The 2 fell off there, sorry. Solve for pH. pH minus log of hydronium. That's minus log of what we just calculated, 1.0 times 10 to the minus 11. When this is 1.0 times 10 to the minus x, x is the pH, 11, that's basic. Hopefully the silence isn't deafening for you. And once again, it's time for Dr. White to share the fun. If the hydroxide ion concentration, OH minus, is equal to 1.0 times 10 to the minus 11, then what is the pH of the solution? And is it acidic, basic, or neutral? Have fun. And notice it would be an important information. So I'm giving you pH equal minus log of hydronium ion concentration, and the hydronium ion concentration times hydroxide equals 1.0 times 10 to the minus 14. Enjoy. See everybody working on their pH problem. Oh, that makes Dr. White so happy. Thank you. And the votes are coming in. Everybody see this on my screen? Don't look, don't look. All right, I think everybody's just about done. So let's get to work. And the question is, what is the pH of a solution if the hydroxide concentration is 1.0 times 10 to the minus 11? So what are we trying to find? pH. What are we given? The hydronium ion concentration is 1.0 times 10 to the minus 11. And important information, you're given what the pH is and what Kw, named after me, I wish, is. And therefore, you need 2 steps. And first step, you have to solve for the hydronium ion concentration. And we know this. Hydronium times hydroxide equal 1.0 times 10 to the minus 14. If I want hydronium alone on one side, I have to get rid of that. Hydroxide, OH minus. How do I do that? I divide by it. But whatever I do to one side, I have to do to the other side. And I do. Anything divided by itself is number 1. And now I have hydronium. Oops. Equal 1.0 times 10 to the minus 14th over hydroxide. I'll put in the hydroxide. And what was that? Well, you took the time to figure out that's 1.0 times 10 to the minus 11. And that's equal 1.0 times 10 to the minus 3. Get your calculator out if you're not comfortable doing powers of 10 division or multiplication in your head. I am, so I did it. And now are we done? No, we're trying to find pH. And all I found was hydronium. And now we'll do step 2 using this equation. And here we have pH equal minus log of the hydronium ion concentration equal, and we just calculated that, minus the log of 1.0 times 10 to the minus 3. Remember my gift to you, when this is 1.0, 1.0 times 10 to the minus x, the pH is x, in this case x is 3, so that's my pH it's below 7, and therefore it's acidic. And that's how you do that. I gave you a bunch of them to work on. All right, let's look at number 10. What happens to the numerical value? Sorry about that, my ear itched. What happens to the numerical value of the pH of a beaker of water at 7.0 if you add a few drops of concentrated NaOH solution? You should know NaOH, sodium hydroxide, is a base. And when you add a base to a neutral solution or any solution, the pH increases. When you add a few drops of concentrated H2SO4, that's an acid. And when you add an acid to the solution, the pH decreases. Remember, I'm not asking you, does it become acidic or basic? I'm asking you what happens to the numerical value of the pH. Now, let's look at number 11. What happens to the numerical value of a pH of a beaker of important buffer solution? It should be this one, not S, solutions, if you add a few drops of dilute acid solution? And the answer is it stays the same. Remember, buffer solutions resist change in the pH when you add a small amount of acid or base. And dilute, small drops, few drops of dilute acid is a small amount. Next, B, what happens when you add a few drops of a dilute base to a solution? And the answer is it stays the same. Again, buffer solutions resist change in pH when you add a small amount of an acid or base. All right, if you have to add 1.35 times 10 to the third milliliters of a 1.53 capital M NaOH solution, and here's the key thing, to neutralize 1.87 times 10 to the minus 2 milliliters of an aqueous solution, what is the molarity of that solution? And what are we trying to find? The molarity, remember, capital M, molarity of the HCl's, which is the acid. We're given the milliliters and molarity of NaOH, the base, and we're given the milliliters of the HCl. At neutralization, when the pH indicator changes color, if I'd put one in here like phenolphthalein, moles of acid equals moles of base. And this is given to you, milliliters of acid times molarity of acid equals milliliters of base times molarity. Now, we're trying to find, actually, I got the wrong thing crossed out. Should have been milliliters over here, not the molarity. Oops, mistake. But we're trying to find the molarity of acid. We're have to get rid of milliliters, divide both sides by milliliters. And this is what I've done. And molarity equals milliliters of base, molarity of base times divided by milliliters of base. And notice milliliters cancel out. I'm left with molarity. And do the math, three significant figures, and that's the answer you get. And I've given you some more of the same here. All right, any questions about acids or bases? I think I've covered it pretty thoroughly. Now, once in a while, I forget things, rare but true, even at I have a photographic memory, but sometimes I forget to take a picture. Oh, is that lame? But anyways, did I talk about drain cleaner in here yet? Nope. Guess what? It's time to talk about drain cleaners. Now, the home I live in, which I bought a long time ago, when I first moved in, within about 2 weeks, or when I moved 3 weeks, I moved in, my kitchen sink got stopped up. So I did what new homeowners do. Instead of thinking like a chemist, which I should have done, is I called up the local rotor rooter man. Nice gentleman came out and put, the rooter thing that cleans out your uh, sink, mainly the trap and also the line going from my sink to uh, where it goes out of my home. And lo and behold, it was unstopped. And within about a week and a half, 2 weeks, it was stopped again. Now, first of all, I should tell you, never throw grease or other things down your sink, especially grease, because they harden up. If you cook with bacon, don't throw that down your sink. Take it carefully, put it in I have a Pyrex measuring cup, and let it cool enough that you can throw it in a Ziploc baggie, and I double bag it, put it in your garbage. That way you won't clog up your pipes in your kitchen. Well, anyways, there's a warranty, 6 months, and I called them up politely and said, stop now. Oh, I'm sorry. He comes out, does it again. And at this point, I'm working at a company as a senior manager, and I'm wasting time at home waiting for this guy to show up. He was on time, but still, instead of going to work, I had stuff to do. It happened a third time. And he comes out and he apologizes profusely. And I'm not mad at him. And he says, all right, here's the stuff I'm going to also put down the sink. I said, can I look at the bottle? I'm a chemist, organic chemist. And I am. I looked at the bottle. I said, nah, ain't going to do nothing. It was some soap and a little other things, surfactants that wouldn't do the job. So guess what? He pours it down, cleans up within a week. It's clogged up. Now, at this point, I don't care about the money I paid him. It's more I'm wasting time having to stay at home and wait for him to show up and not be effective. So I figured, all right, I'll do something smart. And once in a while, I even do that. And I went to the local Home Depot. And not that I'm getting kickbacks from them, but that's where I went. The people there are very nice. And I'm standing this whole wall of drain cleaners. So I pick up a couple of bottles and I see hydrochloric acid. It's an acid. And I'm wondering, which one do I buy? There are all these name brands and everything. And a nice gentleman who works in the area of plumbing and everything comes up to me. Can I help you, sir? I said, yeah. And here's where Dr. White once in a while uses my noodle, and otherwise known as my brain. I said, all these drain cleaners, which one does the plumbers use? And just like that, he immediately says that one. And which one was it? You're going to have to wait while I open up the website for that. Everybody see hair and grease on your bottle? Now, it used to be called this hair and grease remover or drain cleaner, and now it's called Instant Power. This stuff is great. I bought a bottle of it. Now, it works great, and I'll tell you about it in a second, but let me finish my story. So I look at the back of the bottle and I read the ingredients, and it says potassium hydroxide, sodium hydroxide, and a few other things. I said, oh, those are all acids. This is a base. And the guy said, no, this is an acid too. I said, excuse me, I've got a PhD in synthetic organic chemistry, and I've got a number of US patents. I know an acid from a base. This is a base. And he started, no, it's an acid. Immediately I realized, don't argue bases, acids and bases with someone in Home Depot who's being nice to you. So I said, well, thank you for helping me. He said, you're welcome. I bought it, took it home, followed the directions. Boom. I did actually twice because I figured it was really bad. And the only thing I did different was uh, instead of letting it wait 15 minutes, I let it go 45 minutes each time. Also, using my chemistry knowledge about the rates of chemical reaction, when I went to pour water, which they say flush it, instead of using it from the tap, which comes out cold first, I got a bucket, went down to my utility room, took hot water, and did it twice. 10 years later, I had to do it again. And it just recently it stopped up a little. I have a double sink, and the other sink I had to do, I think just because it's a drain sink, yuck gets in there. Is that chemical or not? Yuck, but it cleans that out too. Now, couple things: sodium hydroxide, potassium hydroxide are at high concentrations dangerous chemicals. But relax. First of all, this is the only, I should have realized it when I was at the wall, but luckily the uh, gentleman helped me. It was the only product on that whole wall of drain cleaners that was in a heavy Ziploc bag. On the outside of the Ziploc bag, it said, wear proper eye protection. Whenever I do that, I put on goggles just to be safe. Nothing's bad ever happened, but you always protect your eyes. I also wear a long sleeve shirt or top, or as I have at home, a lab coat, just to be careful. And it works beautifully. A number of years ago, my brother-in-law called me up. He said, my bathroom sink is all clogged up. And besides my sister, they also had at that time 5 sheepdogs in the house. Talk about fur flying all the time. I said, get this, I'll come over and do it. He said, no, just tell me what I should do. And it did work perfectly. Over the years, I've had a number of students come to me and say, how do you do that again? I tell them what product, and they do it. And that works great for both the bathroom, if you got hair clogging it or other stuff, or your kitchen. And just wear proper eye protection, take precautions, cover any skin on your arms and all that. I do. I've always played things, the worst can happen, make sure I'm protected for that, even if it never does and never has, but still. And that's a great product. I don't get any kickbacks. And again, I keep a bottle this size in my house for emergencies. I think over the last 22 years, I've used it 4 times, 3 times in my uh, kitchen, and once recently in my bathroom sink, which finally started getting slow and clogged up. And over all these years, it needed a clean out. And it worked beautifully. If you ever forget this, feel free to contact me by email and I'll send it to you. And students do that. And with that, I'm going to do something unusual. I'm going to end a little early because we can do the rest on Wednesday. Don't forget Wednesday. I will be doing, but I'll cut it out of the video, how to interview. There's some great tips, and students who have followed them have had amazing positive results. And also, I'll have a surprise for you. And I'll cut that out of the video too. And with that, I'm going to let you out a whole couple minutes early. Shh, don't tell the dean. I haven't done it all semester, but I will. And with that, goodbye, gang gazoon. I'll see you on Wednesday.